Hokie dokie. Welcome to Math 1524 Lab 5. Let's work this lab out together. This is a very long one, so let's jump right into it. Dealing with new Excel commands, the $sign. It's not new. You used it before. They'd say download the data, click on the first practice sheet. So VFC, okay. Variable cost, fixed cost, quantity. They're kind of going over old equations you should be familiar with. Fixed cost 100, variable cost is 3, quantities are given. Let's start by entering the incorrect formula. So what they're going to have us do is just calculate cost with the given variable cost, quantity, and fixed cost by doing this here in C5. So I think I've gone ahead and done that here. So you can see the formula. I've done variable cost times quantity plus the fixed cost. Hit enter, you get 115. You drag this down and they say what seems to be the issue. Well, none of these are right. Why are none of these right? Well, because variable cost and fixed cost should stay the same the entire time, and in dragging this down, this one, this calculation for 0 was referencing these two cells as its variable cost and fixed cost, which is wrong. And then you had the same problem with this one. There's no value because you're using these two as your variable cost and fixed cost, and so on. So then they have us do it another wrong way. Let's try again in column D. You want to use $sign for any row or column names you don't want to change. So try it again. So I think I've tried this one. Where they're having you use $signs on everything. So the same formula, just with $signs on everything. And the problem with this is that they have locked in the variable cost and fixed cost, which is good, but it's also locked in the quantity of 5, because watch what happens. We just get 115 because there's no changing, there's no moving parts of this equation if you're locking everything in place, and so you get 115 every time. So now to enter the total cost correctly, we want to lock variable costs and fixed costs in, but we want to let the quantity move freely. So we're doing variable cost times fixed cost. What I like to do is just go ahead and type everything in without $signs and then add them after the fact. So variable cost times quantity plus the fixed cost. Now, what do we need to keep in place? We're keeping the variable cost, the 3, in place. So that's this first one here. So we do $sign around the B. And then the B5, the quantity, we want to leave the same. And the fixed cost, we want to lock in place. So we do that, hit enter. We drag this down. And as we can see, as we click through here, maybe we can do like this. As we click through each of these, you can see that it's using the new quantities each time, the different quantities, but it's using the same variable cost and fixed cost. All right, let's keep it pushing. That was it. Okay. Square roots in Excel. So eventually you're going to have to use the function square root. So they say in A12 type square root of 4. I've already done that here. Square root of 4, it's not that crazy. You get 2. Okay. And in A13 type the square root of C2. So here we'll do equals SQRT of C2. So square root of 100. You see it automatically highlighted it. Square root of 100 is 10. You should see 10. One more example. Click on A14 and do the square root of B6 and E10. So square root of E6, so E6 over here, times what we said, B10, maybe 30. So 62.45, is that what they said to do? I think I did the wrong ones. B6 and E10. Did I do those backwards? I did do those backwards. That's silly, right? Let's swap them, B and E. Little dyslexic moment there. All right, 43.59. All right, 43.59. All right, that's it. Analyzing profit. In Unit 2, you studied break even, which is the point at which the company's total revenue and total costs are equal to each other. In other words, where the profit is 0, blah, blah, blah. Okay, new business terminology, review the basics. We know we have revenue, cost, and profit, revenue, and cost. And then we'll have 2 new business terms, contribution margin and target profit. Okay, Okay, I'll just do this real quick. When profit's greater than 0, you have a profit, and you have a loss when the profit is less than 0 or negative, and you break even when the profit is equal to 0 or really passes the 0 point. So looking at an example, Maple Company produces benches. The variable cost is $31. They sell for a price of $75. And the fixed costs are $8,000. They sell 250 benches. So selling price $75. Items produced and sold $250. Cost per item. The cost literally is the cost for the company, so that's the variable cost of $31. And then variable cost total would be, I guess they're saying like 31 times the quantity, so 31 times 250 maybe. And then fixed cost 8,000. Cost would be the 31 times 250 plus the 8,000. Revenue would be the price times quantity, so 75 times 250. And profit would be revenue minus cost. All right, they have all the answers upside down here. Let's not waste any more time. All right, we're using P, V, and FC and Q to represent price, variable cost, fixed cost, and quantity. Okay, giving these formulas here. Okay, contribution margin. Contribution margin is just the difference between the selling price and the variable cost. So it's like per unit, it might cost you so much to make it, but you're selling it for some price. And so the difference, the actual like profit you make per item, is the contribution margin. For the Maple Company, what was the contribution margin per bench? Well, if they were selling for 75, but it costs you 31 to make them, if you do 75 minus 31, you get, what was that, 44? So 44 is the contribution margin for the benches. Now rewrite the profit formula in terms of the contribution margin. And so if you think about it, $44 for that example was what they were making per quantity. Like it was the profit they were actually accruing per quantity. So it'd be like 44 contribution margin times the quantity they sold, and then you would still have your fixed cost that would be chipping away, it'd be in the negative direction for your profit. So contribution margin times quantity minus fixed costs. All right, target profits. Click on the second sheet, target profit. We're going to enter the Excel formulas in E2 and F2 to calculate profit and contribution margin per bench. The values are entered for you. Okay, I might have started with this already. Yeah. Okay. Set. I think at some point they tell us to do profit, right? E2, F2. Okay. Yeah. E2 and F2 are the profit and the contribution margin. So to calculate profit, I've done just a simple variable cost times quantity minus let me redo that. Profit, I've done price times quantity for the revenue minus variable cost times quantity minus the fixed cost. All right, because the price times quantity, the revenue, that's always positive, but anything that's contributing to your expenses, to your costs, should be subtracted, should be negative. So your contribution margin is just the price minus the variable cost. And then leave it at that. Target profit just refers to like specific profits that you're aiming for or a company is aiming for. So target profits, let's call the target profit TP, and the corresponding quantity required to reach that target QR. So recall the formula above, contribution margin times quantity minus fixed cost equals profit. And so target profit would be contribution margin times QR, the quantity required to reach the target profit, minus variable or minus fixed cost. So then if we wanted to solve this equation for QR, we would add FC to the left side and we would divide by CM. So we can see down here QR is equal to TP plus FC over CM. TP plus FC over CM. All right, return to the target profit sheet, enter the target profit of 5,000, then use a formula. Okay. So we just type in 5,000 here. Quantity required, this is where that formula we just talked about for QR, what was it? TP plus FC, fixed cost, divided by the contribution margin, CM. Is that right? Let me just make sure. That'd be embarrassing. TP plus FC over CM. Yeah. All right. So 295 is the quantity required to reach the target profit of 5,000. with these values, with that criteria. All right, you should see 295. We do see 295. Why should you round up the QR value to a whole number? Because QR is representing a quantity, and you can't sell non-whole number values of objects. Okay. Suppose the Maple Company raised their selling price to 85. So drag down all the same values. Drag down your formulas for CM and QR. What are the new values for CM and QR? Okay, so all we're changing is the price, the selling price, from 75 to 85, but all the values are still the same. So if we drag down the profit, we see how big of a profit gap we have, like how much more profit we're gaining just by selling the product for $10 more each. And then they say just to drag these babies down. So I'm going to keep this target 5,000. Yeah, let me make sure. Yeah, target profit still 5,000. Okay, so what are the new values for CM and QR? So CM went up by 10 because you're selling it for $10 more. So the difference between production and selling price is, $10 difference. And so the quantity required went down by 54 because you're selling them for $10 more each. So you don't have to sell as many to reach the target profit of 5,000. So describe what the changes in those mean for the company. I mean, I kind of just did. You can sell less if you price them more and still reach your target profit. What target profit should you use in the QR formula if you want to break even? Well, the target profit, the profit for breaking even is just 0. So your target profit, if your target is just to break even, is 0. Repeat the row values for PV and FC in row 4. Add the break-even target in G4. Okay. So now we're doing a target profit of 0, and we're dragging down just the same. Yeah, okay. So dragging down like, I think all the same things here. 85, 31, blah, 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 blah. CM would be the same, but it's just the quantity required they're asking about, I guess. And so your quantity required just to break even would be 148. So your quantity required to break even obviously is much less because your target profit is much less. Okay. CM would be the same. I don't know if we addressed that. Your contribution margin is still the same because you're still selling things for the same price and they still cost the same to make per unit, so that doesn't change. Okay. Break-even analysis. Break-even analysis is presented well using a connected scatter plot showing the cost and revenue together. So we'll get into that as we work through this. Click on the next sheet, break-even analysis, selling price, PV and FC are entered for you. Starting in cell 5, enter a list of Q values from 10 to 300 in increments of 10. I think I might have done that already. I like, again, just to use the method of typing 10, typing 20, highlight those two, and then just drag it down to 300. That's my preferred way. If you want, you could do like a formula. All right. Enter formulas for revenue, cost, and profit. Don't forget to use the $ correctly. So what do we know about revenue? Revenue is price times quantity. So selling price times quantity, and the selling price is 75, and we want to make sure it stays locked in on that cell for 75. So instead of just typing A2, we're going to do $A, $2, and we keep the A5 with no dollar signs because that's referring to the quantity, which needs to be able to change as we drag down. Likewise for the cost. Cost is the cost per item. Don't know why they didn't call that variable cost. Variable cost times quantity plus fixed costs. Now which values need to stay locked in? These ones up here. So they're nicely color coded. If you get confused, I know I do. So we're putting dollar signs just around the blue and the purple. Entered information. I don't know. Hit enter. Profit we know is revenue minus cost, R minus C. All right, so profit's not looking too good if you only sell 10, right? So what we're going to do is drag this down, highlight all 3, drag down to 300. All right, and what are they asking? assume, or what does it say? Approximate the production level when the maple company will break even. Maple company will break even when the profit is equal to 0. So the profit crosses 0 right here. So if you had to estimate, I don't know, it looks like it's barely negative, but then it jumps to 360. So, I mean, what are they selling? They're selling for 75 and it's at negative 80. So you have to sell 182 to fully break even. Okay. 182 is the quantity production level where you break even. Create a connected scatter plot of revenue and costs with quantity on the horizontal axis. What do you notice about the two graphs at the break even? Quantity. So highlighting quantity, revenue, and costs all at the same time. Insert scatter plot, connected plot, and we know that at the quantity, I think I said the quantity was 182, right? Hopefully I didn't say 282. I don't remember. 182 should be about our break-even point, and you can tell at about 180, 182, the revenue and cost intersect, and that's exactly what they said. The revenue and cost are equal whenever you break even, because that's another way of describing profit equal to 0. Sustainability versus profit. This is just describing, like, do businesses want to focus on just making more money, making more profit, and not caring about the environment, or should they spend a little money on the front end to be more sustainable and be more like environmentally friendly if it's going to cost them some money? Okay, so we have MJ is an entrepreneur who's looking to start up a new reusable water bottle company. MJ is hoping to only use recycled plastic in producing the water bottles. Brand new plastic is cheaper than recycled plastic. Okay, so MJ contacts a friend, JM, crazy names, all right, who works as an accountant. They discuss the options. Okay. Doing market research, they determine the following facts. Variable cost is $150 for new and $320 for recycled plastic. Selling price $825. Fixed cost $67,500. Target profit's $10,000. Go back to target profit and enter the necessary numbers and use the formulas to answer the following questions. Okay, what is the contribution margin when using the new plastic? Okay, so I might let's go ahead and just enter the numbers we need here. We're going to just enter stuff for this. Do they tell us how far to go down or anything? I guess not. Okay. We're just going to start at, I don't know, 810. All right, so variable cost. We know the selling price is $825. We know the variable cost is $150 for new. And I'll do the new plastic in this row. I'll do recycled plastic here. So we got $825 and then $320 for variable cost there. Fixed cost should be the same, so $67,500. Drag that down. Quantity, I guess we don't know quantity yet. Okay. Profit, target profit's really all we know, so 10,000. Okay, is that everything we have? Yeah, okay. What's the unit contribution margin when using the new plastic? So you can just drag this down, I think. Yeah. So $675 when using the new plastic and $505 when using the recycled plastic. How many water bottles do they need to sell to reach their target profit when using new plastic? So I think also we should be able to just drag this down. Let's see what we can just drag down here. So there's profit. But I guess we don't have a quantity here, so that's going to look stupid. Let's just do this. There you go. As long as this doesn't reference the empty cells, yeah, we should be good. All right. So, getting back to it. These are the quantities required to reach this target profit, right? So, sorry, it's a little small, navigating, doing the split screen here. How many water bottles do they need to sell to reach the target profit when using new plastics? That would be 11,481, and when using recycled plastic, 15,347. So, I mean, 4,000 more they have to sell to reach that profit when they're using recycled plastic. How many water bottles do they need to sell to break even when using new plastic, when using recycled plastic? So to break even, let's just change these to 0 real quick. So to break even, they need to sell 10,000. That seems like weirdly too exact. 10,000. Okay, whatever. They need to sell 10,000 to break even, and they need to sell 13,366 with recycled plastic to break even. Okay, let's keep going. They decide that sustainability is their highest concern, so they're going to go with recycled plastic. They realize that consumers are willing to pay more for bottles that are made from recycled plastic, and higher prices sometimes attract a niche market as well for having specialty. Oh yeah, that's pretty fun. I forgot I had that. Niche is how you pronounce that. That's fun. Okay. Like reminded me I had that pulled up. All right. Niche market for having a specialty good. So they're trying out different options here, and they basically, I guess they just want us to use these to calculate different options. Okay. I don't even know if we need Excel or not. Let's see what we can do. Let's see what we have. All right. Selling price of $10, but a quantity of 11,000. So they're just having us calculate. Okay. So variable costs and fixed costs should be the same, but if the selling price is 10, 13, and 17 with different quantities, okay, we're gonna drag these down. Let's go ahead and drag this down. We'll get rid of these first two, or all these, I guess. And we're gonna watch how the profit changes when we input different quantities for these three corresponding examples, looking at these guys here, right? So we're do something like this. All right, so quantity of 11,000, 8,000, and 5,500. So these are the different profits that we would get with these selling prices and quantities. Yeah, all right. So what's the highest profit they're getting? It's this one in the middle, 10,900, and that's for selling price of 13 and a quantity of 8,000. So based on your answers, which selling price would MJ choose? Hopefully the one with the highest profit there, because it's kind of like an in the middle sort of value. It's like the middle selling price, and you know, you don't have to sell a ton, but you don't want to sell too few, I guess. I don't know, something like that. Click on the fourth sheet. Break-even analysis. Oh my goodness, no. I just want to make it bigger, Jesus. All right. Enter the appropriate numbers for PVFC from your chosen option. Okay. 13, 8,000. So we're doing what now? I have no idea. What are we doing? I think we're just maybe changing these up here. Fourth sheet. It's probably because I haven't clicked on the right sheet. That's the fourth sheet. Okay. Selling price. $13. Cost per item is still, God, what was it? Just getting a nightmare jumping back and forth. Hold up. All right. Can I just copy these? Maybe just copy these first three. Cost per item 3.2, fixed cost. Yeah, that works. Okay. And they want us to do the quantity. I'm just going to bounce back and forth. Quantities 1,000 to 15,000 in increments of 1,000. So 1,000, 2,000. Highlight these, and we're going to 15,000. So now we can just calculate revenue, cost, and profit. We can probably just copy these. It's going to be fun. Control C, Control V, and I think that's doing it. Yeah. 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 All right. Highlight all these. Drag this down. Okay. What do they ask? Create a connected scatter plot that shows the break-even point. So that would just be quantity, revenue, cost, insert, scatter plot, connected lines, you can see the break-even point where they intersect approximately at a quantity of 7,000. Okay. So about 7,000. You can see that's where the profit has also gone from negative to positive, just barely into the positive. So I mean the quantity might be 6,900, something like that. Okay, use your graph to approximate the break-even point. So the break-even quantity may be 6,900. Now use a formula to actually calculate the break-even point more precisely. So more precisely, what do we need? We need the profit to equal 0, revenue minus cost. Okay. How should we do this? A couple different ways, so I'm trying to navigate the options here. Let's do contribution margin. So like if they're selling it for 13 but it costs them 3.2, contribution margin is 9.8. So that's how much they're actually making in profit per bottle. And the fixed costs are 67,500. So if we just do the fixed costs divided by the contribution margin, we should find where they have to break even, or where they break even. I wonder if that was given to us on, I don't know if it was. I'm not going to focus on that. Okay. All right. Let me just do that. So what we're going to do is fixed costs divided by the contribution margin, so the difference between the selling and the variable cost, selling price and the variable cost. So 9.8. And that gets us 6,887. So they would have to sell a rounded up number of that. So 6888. This is how many bottles they'd have to sell to break even with the selling price, variable costs, and fixed costs. Okay. So that was the formula. What are the corresponding break-even costs and revenue? Corresponding break-even costs and revenue. So that just means like if you plugged in 6888 into the variable costs and or into the revenue and costs, right? Revenue and costs. Yeah. Okay. So let's just do this real quick. The revenue would be the selling price times the quantity, the break-even quantity. Okay, that's how much money they make. This is again the revenue. And then we'll do cost here because they have it cost then revenue, I guess. So cost would be your cost per item times number of items plus fixed costs. So this is your cost and your revenue corresponding, do like a nice green, corresponding to your break-even quantity. So that's the idea. That's the revenue and quantity, and you'll notice that they're supposed to match, but this is the closest we can get with a whole number quantity, right? So we needed the revenue just to be over the quantity, just barely over the quantity, because of, we need to break even. We don't want to keep the cost more than the revenue because we won't earn a profit that way. So 6888, they have the answers there. Okay. Do you feel like companies can capitalize on sustainability and make their products make their products both more sustainable and more profitable? I would say they can capitalize on sustainability and make their products more sustainable and more. I mean, yeah, technically. It's like the whole idea of like people will pay more for like eco-friendly things, and they'll support companies if they know they're eco-friendly, and so you can charge more for that naturally, and you can hopefully be more profitable because of it. If companies are like too greedy and they're charging too much for sustainable things, then maybe that's not ideal. What factors should they consider? You can charge a lot but not too much, right? You can charge more for sustainable products. You just don't want to charge a ton. But maybe you do want to charge a ton because people buy Teslas and those cost a truckload of money, I don't know. It's a little crazier than water bottle example here. But all right, let's get into economic order quantity. How are we doing on time? About 30 minutes, and the rest of this lab is on economic order quantity. Looks like a lot, maybe a lot. Let's get through it. All right, MJ. The company they started has become very successful. In this lab, you're going to study the economic order quantity model and its applications in inventory management. The EOQ is the order quantity that minimizes the total holding costs and ordering costs. Okay. Defining the variables. There are a few assumptions in the basic EOQ model. Pay close attention to these. These might help on a quiz coming up. First, demand for the product must be constant over the entire year. For example, the basic model would not apply to snow tires because that's a very seasonal thing. So the demand is not constant for snow tires throughout the entire year. Another example might be like bathing suits. Bathing suits have a high demand in the summer, maybe not so much in the winter. Okay. Second, orders must be placed at regular intervals over the year and a new order delivered in full when the inventory reaches zero. So you're like placing orders of certain amounts and you're waiting for that order to that inventory to run all the way to zero before you order more, but you're ordering at regular intervals. Okay. EOQ takes into account time of reordering, cost of placing an order, and the cost of storing the product. In addition to the costs to produce or purchase, you have to think about shipping and handling. Okay. Also, holding costs, which is like storing the inventory until it's sold. The economic order quantity is the ideal number of items to order so that the total annual cost of ordering and storing are like the big keywords here. It's the cost of the ordering and storing that needs to be at a minimum. So it's like what's the quantity we should order so that ordering and storing costs together are minimized. All right. Suppose you own a retail outlet that sells MJ's water bottles. They become the supplier, so MJ becomes the supplier, and you want to determine your EOQ to minimize your costs. So the EOQ is not for MJ, it's for the retail store. It's for us. With our store, we're trying to minimize our costs of buying MJ's water bottles and storing them and selling them and blah, blah, blah. All right. Purchase price is $24 a bottle. Demand for your store for these bottles is $30,000. They place orders 600 at a time at regular intervals. Write down all the work calculation below. Okay. So what's your annual purchasing cost to meet the full demand? The full demand is 30,000 bottles, and you have to purchase them for $24 a bottle. So 24 times 30,000. Okay. How many orders do you need to place in to meet the annual demand? The annual demand, again, 30,000. And how many orders? If they're ordering 600 at a time, you would do 30,000 divided by 600 to get 50, I believe. I hope that's right. Let's see, we got the answers upside down. 30,000 divided by 600 is 50. All right, 50 orders per year. Suppose it costs $16 in fixed cost to place each order. What's your total annual ordering cost? Well, if you have 50 orders times 16 per order, that's whatever that is. $800 upside down here. Okay. What's the largest number of water bottles you could have in your inventory at one time? Well, the idea is you're only ordering 600 at a time, and you don't order more until you've hit zero with your inventory. So the largest you could have is 600. The smallest number of bottles you could have at one time is 0. So use those two numbers to calculate the average. The average, or the average between 0 and 600 is right in the middle at 300. So the average is 300. Suppose your storage expenses are high, resulting in an annual holding cost per bottle of 25% of the purchase price. The purchase price was $24. So 25% of that, 1/4 of 24, is $6. So the annual holding cost per bottle is $6 per bottle. Combine this with the average number, the 300 we just found, to calculate your total annual holding cost. So it's just the $6 per bottle times 300, the average number of bottles we have in store at any one time. So 6 times 300, 1,800. All right. Using the given information, my dumb head was typing out all these numbers, and I realized they gave it to us on the next page. All right, so these are just the numbers we just dealt with. They just have it organized in a chart where they've labeled each of the values with a variable, P, D, Q, S, and H, respectively. and they've given us general formulas to calculate basically what we just calculated, but just in a general formula sense. All right, order size 600. Okay. EOQ. Okay. So you need the general formulas in the second table, the ones I've highlighted here, to write total cost as a function that depends on Q. So total cost as a whole is the total annual purchasing cost, total annual ordering cost, total annual holding cost. So adding all those together would be this, specifically P times D plus D over Q times S plus H times Q over 2. Bam, bam, and bam. And then they say which one of those three formulas you wrote does not depend on Q. So of these three, which one doesn't have a Q in it? That'd be the first one, the total annual purchasing costs. And so if it does not depend on Q, and you're just trying to find the EOQ, the quantity, then you can kind of ignore the total annual purchasing cost. It's not going to it's not going to play a difference. It's not dependent on the quantity, so it doesn't affect the EOQ. So you have a total cost, like a simpler total cost formula here. You still have to consider the total annual purchasing cost, like it still plays a role into your cost, but for the EOQ, you don't need to think about it. Okay, so we're going to investigate the optimal ordering quantity Q. Let's start working with Excel. First, use the table above to fill in the specific values for D, S, and H. So D, S, and H above were 30,000, 16, and 6. 30,000, 16, and 6. And in place of Q, we're just going to use Q. Okay? So now to use these values with the general formulas above to write this and that. So this is the annual ordering cost. Annual ordering cost right here, D over Q times S, would be D, 30,000, over Q, which we're going to leave as Q, times S, which is 16. So 30,000 over Q times 16. Annual holding cost come from this, H times Q over 2. H is 6. Q we're going to leave as Q, and then over 2. So 6 times Q over 2. You could call that 3Q if you wanted to simplify. All right, return to Excel. Click on EOQ. Boom. You'll examine 3 cases. Type 200 in A2 and go from 200 to 900 in increments of 50. Okay. 200, 250. Highlight these two. We're going down to 900. Easy peasy. Use the formulas for ordering and holding costs to write the appropriate formulas in B2 and C2. Okay. Yeah, we're still using these values. Okay, yeah, we're just going to use those. So 30,000 equals 30,000 divided by Q times 16. Yeah, all right. Hit enter. 6 times Q over 2. 6 times Q over 2. Now it's, I guess for the, and then in place of Q, we don't type Q, we click on that Q. Okay, we also have to start with equals. Sorry, I was thinking about a bunch of different things at once. 6 times A2 over 2, make sure you got the equals. All right. Going back on what I said, I would not actually recommend typing 3 times A2 in this case, because sometimes your holding cost, your 6, might change to something else, and it'll be easier to leave it as 6 times A2 over 2. All right. We're gonna, what are they saying? Okay, write the Excel formula in D2, calculate the total cost, drag all 3 down, 2 decimal places. Okay. Total cost. Well, these are the ordering costs and the holding costs. We're going to call the total cost just the sum of these two together. We're going to highlight all 3, drag this baby down, and we have all these. And then they say just highlight everything, I'm pretty sure, and insert a connected scatter plot. So the idea is you'll see the total annual ordering costs start high and work their way down. Total annual holding costs work their way up, and the total cost is almost like a parabola that goes down, hits a minimum, and goes back up. And total cost being a minimum, we want our cost to be at a minimum for some specific quantity. And we can see that quantity also where these two ordering and holding costs intersect. So that's kind of a hint as to what's coming here. You should see 3 graphs. At what value of Q is the total cost minimized based on your graph? The minimum of the total cost, this gray curve, is at a quantity of 400, just looking at the point there. And the cost itself corresponding to it is 2,400. So what do we say? 400? 400 and 2,400? Yeah. All right. 400. That's the EOQ. 400 is the EOQ. What's the total cost? 2,400. Case B. Increase the annual holding cost. Okay. Leave 17 and 18 blank. Make a copy of the first table. 17, 18 blank. Copy of the first table. So the whole table. Okay. Control C. Enter. Okay. Easy peasy, right? And they ask us to change. What if we double the holding cost percentage? Recall we assumed the annual holding cost was 25% of the 24. That's what gave us the 1/4 of 24, or the $6 holding cost. If we change that to 50% of the purchase price, then adjust the corresponding formula. So this is where I was saying, like, you'll have to change the holding cost from 6 to 12, because 6 was 25% of 24 and 12 is 50% of 24. So we just change that, but we have to make sure to drag just this one down so it changes everything else. It doesn't change everything else, but it changes the total cost. Create a connected scatter plot. Okay, so highlighting everything. Yeah, insert connected scatter plot. Okay, looks similar, a little bit different. What do we notice? Minimum for total cost is a little earlier, right? It's more like a little before 300, maybe like back here a little bit. Okay. So approximating the Q value would be, I would say, a little less than 300, because you can see the intersection's not right at 300. It's a little bit less. So I'd say, like, I don't know, 280. 280 could be the EOQ here, or the Q value. And then what's the new total cost? Low iffy, but the one at 300 is about 3,400. So maybe a little less than 3,400, maybe like 3,200. I don't know, 3,300. So maybe 3,300. Compare this new chart to the original. How did doubling the holding cost affect the ideal quantity? Think about why this happened. So in the first one, the ideal quantity was about 400. And in this one, we said it was about 280, right? So increasing the holding cost, doubling it, made the ideal quantity go from 400 to 280. It lessened it, right? It made it decrease. Think about why this happened. Well, I guess if the holding costs go up, then you can't order that many per order. You can't place an order for like more than 400 compared to the what am I trying to say? Basically, your quantity per order must go down, because if the holding costs are more, you're getting charged for the extra quantity more. And yeah, okay. So KC, increase the fixed cost per order. Okay, tripling the order cost. So leave 2 blank rows again. Copy the original. Originally, we assumed the cost per order was 16. If we triple that to 48, do all the same stuff. Okay. So we're going to copy the original. Control C, skip 2 rows, and we'll hit enter. And we're changing the ordering cost. That 16 that they mentioned, we're tripling it to get 48. Hit enter. Make sure to drag this down. And we're done. We just got to highlight all these. Insert connected scatter plot. Ba-boom. All right. So what happened? The quantity where they intersect, or where the total cost is at a minimum, went way up, right? So we can see this intersection here, I would say just to the left of 790, maybe like 695 if we had to estimate it. So Q would be about 695. What's the new total cost at that point? I would say approximately, if it was what, 41.57 there. It might be 41.20. I don't know. 41.20 at that point. How did tripling the ordering costs affect the ideal quantity per order? So tripling the ordering cost made it so, funny enough, I guess we wanted to place, I know that makes sense actually. We wanted to increase the quantity per order by a couple hundred, because if we increase the cost per order, we wanted to make sure we could still eventually get all the water bottles, the 30,000 or whatever we were aiming for. But if it cost more per order, we needed to make sure we got more quantity in each order so we could place less orders throughout the year. All right. Look at all three cases. What do you notice about the holding and ordering costs at the EOQ? Okay, we've already addressed that. Holding and ordering costs intersect at the EOQ. They are equal to each other at the EOQ. Estimating the Q value, blah, blah, blah. How might you adjust your method to improve the accuracy of your estimate? Okay. Okay, so looking at the graph is not the most accurate way. How might you adjust the method above? So if we were adjusting this method, I would probably not go in quantity intervals of 50. You could just go in quantity intervals of 1 and get exact answers, so you don't have to approximate anything. It'd be very easy to just go up by 1 each time and find the minimum based on that. All right, we're doing pretty good. 46 minutes. Oh, we're on the last. Oh, we're crushing it. All right. EOQ formula. So there's a better way to find the quantity Q that minimizes the cost. Finding the EOQ is simply an optimization calculus problem. To review, to optimize a function, finding the max or min, you need to find its derivative and set it equal to 0. For the EOQ, minimize the total cost function C, or cost. So we need to find the derivative C prime. Again, they give us this equation for total cost, the ones that only included the Q. We will calculate C prime for you. So they've done that here, treating Q as the main variable and then treating S, D, and H just as constants. They don't change, right? So they found the derivative right here, and they said show that the derivative equals 0 when Q is equal to this. So what you would do is plug this square root of 2SD over H in place of that Q, and you would simplify everything and show that it equals 0. Briefly, this is what happens. You have a square root of something squared, so the square root and the square cancel each other out. So you're left with negative SD over 2SD over H. The SDs cancel, and then you have like 1 over 2 over H. So you flip it, you have negative H over 2. Negative H over 2 plus H over 2 equals 0. All right, so the important thing here is that because the quantity that made C prime equal to 0 was this, that means that this is the quantity for which the original function, the cost, is at a minimum. Therefore, the quantity for which the cost is at a minimum is your EOQ. Okay. What does this formula tell us will happen to the EOQ if the cost per order S increases? Okay. So looking at this little equation for the EOQ, if S increases, S is in the numerator, so the quantity should increase. If H increases and H is in the denominator, then the quantity, the EOQ, should decrease. All right. Review all your previous work and write the D, S, and H values in the table below. Do not put EOQ yet. Okay. D, S, and H. For what? Case 1, what was it? Demand is 30,000, I think, for all of them. S was, oh God, the same for the first two. I think it was like the 16. And then the holding was the 6, 12, and then 6, respectively, for each case. Go back to EOQ. Start with case 1 and A17. Enter the formula to calculate EOQ. Okay. A17, EOQ. Okay. A17, EOQ. EOQ is the square root of all the stuff we just said. So 2 times SD over H. 2 times S times D. S times the S was, oh God, I've already forgot it. 16? Yeah, I think. I'm gonna go with 16. 16 times the D, which is the demand of 30,000. And then we're dividing that by H, which was 6. So 400. 400 is the EOQ, and that's actually what we said the first time, right? We can see that intersection at 400. That's the idea. So this is our EOQ right there. Do they want us to do anything else crazy, or just do that for all the others? Oh wait, use a case size. You can drag the formulas for B2, C2, and D2 down to 17 that calculate the corresponding total cost. If you're correct, total cost should be the minimum value in column D for case A. Okay, sorry, my mind is mush right now. Let me process this. Okay. Total cost, if you're correct. Okay, write the EOQ and the total cost you calculated in the table above. Why should you round? Okay, so we're just finding total cost. If you want, you can just highlight all three of these, drag it down. And so all it tells us is that we get 1,200 and 1,200. So we know the ordering cost should equal the holding cost, and we know the max, or sorry, I guess the min total cost is 2,400. That corresponds to 400 because that's the intersection point we found the first time, right? So 400 and 2,400 for the cost. And we just repeat this process for the others. So I think I can just copy and paste this. If we just, yeah, I'll go and I'll still copy. So if we copy and paste, we'll just change the values we need to. So like in case B, in the second case, what was the only thing that changed? I think it was the holding cost doubled. So the holding cost doubled from 6 to 12. We hit enter. We get 282. So if we drag all this down, we get these. I'm just going to highlight the minimum cost. I think 282, what did we say before? I think honestly we said about 280 for the quantity. That's pretty solid. We'd want to make sure to round this to the next whole number, I guess. So if we like format this, they might have said something about that in the thingy. So 283 is the value. Did these just change? Couldn't tell. I don't know. 3394 is the minimum cost. Let's just do the same thing here. Let me make sure. Yeah, that's a whole number. If we copy and paste this here and think about what was the only change, well, I guess we should have copied it from the original. The holding cost for case C, the third case, holding cost was still 6, but the ordering cost was not 16. We tripled it to 48. So we get 693, and we drag this down. I'm going to highlight this. So about 693. I think that's about what we said before. I think I might have said it was a little less than 700, maybe 695, 693. That's pretty spot on. So we get a minimum cost of 4156. So 693, 283, 400 are the EOQs here, here, and here, and the total cost of the other highlighted values, and that's it. You should always round the EOQ to a whole number because it's a quantity. You can't have decimals or partial quantities of items. All right, we crushed that. That was shorter than the last lab. That's crazy. Okay. Very long lab, super fun lab. Hopefully not too bad. Hopefully you learned something from this. Hopefully I answered any questions or addressed any things you had trouble with. Hey, thanks for working out these labs with me this semester, or vice versa. I don't know. Thanks to me for working them out for you, or with you, for you. Thanks for watching. That's all I gotta say. I'm happy I could help work out these labs. If you have any questions, please let me know. I hope this helped. Hopefully you don't have to retake this class and work on these labs ever again. But it's a lot of fun stuff. All right. Call it there. Thanks for watching. Bye-bye.